we are going to discuss about entity authentication. Objectives: the difference between message authentication and entity authentication, to define witness used for identification, to discuss some methods of entity authentication using a password and etc. To introduce some challenge response protocols for entity authentication. Introduction: entity authentication is a technique designed to let one party prove the identity of another party. An entity can be a person, a process, a client, or a server. The entity whose identity needs to be proved is called the claimant. The party that tries to prove the identity of the claimant is called the verifier. Data origin versus entity authentication. There are two differences between message authentication. Message authentication might not happen in real time. Entity authentication does. Message authentication simply authenticates one message. The process needs to be repeated for each new message. Entity authentication authenticates the claimant for the entire duration of a session. Verification categories. There are three verification categories available: something known, something possessed, something inherent. Something known means a secret known only by the claimant. It can be checked by the verifier. Example: password. Something possessed means it can prove the claimant's identity. Example: password. Something inherent means an inherent characteristic of the claimant. Example: conversational signature, fingerprint, voice, etc. Entity authentication and key management. We are going to discuss about this chapter, entity authentication, and the next we will discuss about key management. These two topics are very closely related. Key management protocols use entity authentication protocols. Password. The simplest one and oldest method of entity authentication is the password based authentication, but the password is something that the claimant knows. A password is used when a user needs to access the system to use the system resources. Each user has a user identification that is public and a password that is private. We can divide authentication schemes two groups, one for fixed password and another one for one-time password. Fixed password is a password used over again and over for every access. In fixed password, there are several schemes. The first approach, the system keeps a table that is stored by the user identification. The user sends her identification and the password to the system. The system uses the identification to find the password in the table. The figure explains the user ID and the password file. A stored password and then password sent by the claimant. And then there are various attacks available in the first approach. Examples of stealing password, accessing password file, guessing, eavesdropping, etc. Second approach, to store the hash of the password. Any user can read the content of the file because the hash function is a one-way function. So any user read the content of the file. The figure explains the hashing the password. A for claimant and B for verifier. So send the message. Password file store the user ID and the password. The hash function using the access. Third approach. This is called the salting password. When the password is created, a random string called the salt is concatenated out to the password. Then it is hashed. The ID, the salt and the hash are stored in the file. The figure explains the salting the password. Salting makes the dictionary attack more difficult. The original password is 6 digit and salt is 4 digit. The hashing done over a 10 digit. This means attackers needs to make a list of 10 million items and create a hash for each of them. It is very difficult to find the original message. Fourth approach. Two identification techniques are combined. A good example, the this type of authentication, the use of an ATM card with a PIN. That means personal identification number. one-time password. It's a password that is used only once. The kind of password makes eavesdropping and salting useless. It one-time password have here three approaches. First approach, the user and the system agree upon a list of password. Each password on the list can be used only once. Second approach. This approach, the user and the system agree sequentially update the password. The user and the system agree on the original password P1, which is valid for the first access. During the first access, another password is created. Then it's going on. The process is going on till the process completed. Third approach. The user and the system create a sequentially updated password using hash function. This is function. The user and the system agree upon a original password P0 and a counter n. The system calculates a h to the power of n p of 0, where h to the power of n means applying a hash function n times. Here see the formula of the hash function. The figure explains the Lamport one-time password. Challenge response. In a password authentication, the claimant proves her identity by demonstrating that she knows a secret, the password. However, because the claimant reveals the secret, it is susceptible to interrupt by the adversary. In challenge response authentication, the claimant proves that she knows a secret without sending. In other words, the claimant does not send the secret to the verifier. In challenge authentication, the claimant proves she knows a secret without sending to the verifier. The challenge is a time varying value, such a random number or a timestamp that's sent by the verifier using a symmetric cyber. Several approaches to challenge response authentication use symmetric key cyberation. The first approach, the verifier sends a nodes, a random number used only once, to challenge the claimant. A nodes must be time varying. Every time it is created, it is different. The claimant responds to the challenge using the secret key served between the claimant and the verifier. The figure explains the nonce challenge. And second approach, the time varying is timestamp. The challenge message is the current time sent from the verifier to the claimant. The figure explains the timestamp challenge. Third approach, the first and the second approach are for unidirectional. So A is authenticated to B, but not other way. So we need to the bidirectional. So we are going to the third approach. The figure explains the bidirectional authentication using key hashed function. Instead of using encryption or decryption for entity authentication, we can also use a hid hash function. For example, MAC. The figure explains the hid hash function using on symmetric key cyber. Instead of symmetric key cyber, we can use an asymmetric key cyber for entity authentication. Here, the secret must be the private key of the claimant. The claimant must show her private key related to the public key that is available to everyone. Here also three approaches. First approach, B, encrypt the challenge using A's public key. A, decrypt the message with the A's private key. The figure explained the unidirectional asymmetric authentication. Second approach, two public keys are used, one in each direction. A sends her identity and nodes encrypted with a B's public key. The figure explained the bidirectional asymmetric key approach using digital signature. Entity authentication can also be achieved using a digital signature. When a digital signature is used for entity authentication, the claimant uses her private key for signing. This digital signature has two approaches. First approach is B uses a plain text challenge and A signs the response. The following figure explains the digital signature in unidirectional. Second approach, the digital signature using the bidirectional authentication. Thank you.